This marks a pretty big change in this class for a couple of different reasons. One, in the past, we've mainly been covering material that really wasn't in the book, but if you have the textbook, now is when it will become more useful. We're jumping right into chapter 4. Second thing is we are now using way more finance topics. The first period of this class was really macroeconomics for the most part, and now we're going to have some finance, and we're going to gradually connect those two together. Okay. Lastly, I just want to say that for the material we're going to be covering in the near term, there's a lot of overlap between this and what students tend to see in other courses, future values, present values. Most of you have seen this before, but the problem with this class is that the only prereqs for it are just some principles of economics course. So there are probably some students in this class that have never actually solved for future or present values. So we're going to go through this quickly. This video in particular, if you feel like you're real skilled with this already, you might just go through it really quickly, make sure you got it. I wouldn't advise you to skip it all together, but maybe watch it at 2 times speed and just make sure you've got all the basic ideas down. Okay, so let's think about how money grows over time. I'll call this example 1. Let's say that I save $100 in a savings account for 1 year, and I earn an interest rate of 3%. And I'm confident that everyone out there has dealt with interest rates before, right? So interest rates basically explain or show how money will grow over time. When you're the saver, you'd like to have higher interest rates, of course. When you're the borrower, you would prefer low interest rates, okay? So if you save $100 in a savings account for 1 year, this is effectively what would happen, okay? The future value, which I'm not going to bother defining on the board, but future value just refers to the amount you'll have in the future. It's kind of like a theoretical idea of how much you'll have in the future before you actually get there, okay? Will be based on how much you put in and the interest rate you receive, okay? And the formula that you actually will get for this looks something like this. Okay? So if you save $100 in this account, you'll get your $100 back plus the 3% that you receive in interest. Okay? So this is kind of like your primary payment. That's the amount you put in. That's your principal, right? And this is the interest you've earned. Okay? So you're going to get $100 returned to you plus 3% interest. And of course, the end result there is $103. Now, how much would you have after 2 years? Same thing when you see this type of question, if you think about 2 years, is just to say, well, you'll earn another $3. That's not correct. Interest compounds, okay? So if you leave your money in an account for 2 years, and assuming we're having annual compounding interest, which is what we're going to assume really for all of this class, you don't just add $3 because now your principal has changed to $103. So if we change this now, for example, 2, keeping everything else the same, except now thinking about it for 2 years, the future value you would receive is the $103 that you got after year 1, plus 103 times an additional 3%, okay? So if we're trying to figure out how much we'd get 2 years from now, we would take the first year, that would become our new principal, and then our interest rate would need to be applied to that $103, okay? This is called compounding interest. It's the idea that interest builds upon itself. And this is what makes interest such an incredibly powerful force, okay? If you take $1,000 and you put it into, stocks or savings account or whatever, it's almost unbelievable how much money you would have after 100 years, just because of the way compounding interest works. Interest builds upon itself, okay? So we can use a general formula for this from now on, a formula that probably most of you are familiar with. It just looks like that, okay? FV is the future value, so that's the amount you'll have in the future. That's what we've been solving for in these questions. PV is the present value. It's the amount you start with, okay? So that would be the $100. I is the interest rate you receive. And N is the number of years, okay? I'm just going to write that here just so we don't forget. N is the number of years. So if it's 10 years, N would be 10. If it's 6 months, N would be 0.5. And all of those values will work just fine for our calculations, okay? So if we had $100 in a savings account for 100 years, let's say, then our future value payment will look like this. Okay? And I'm just going to see what that comes out to for curiosity's sake. 3% is not a particularly high interest rate, so this isn't all that great. $1,921.86 is what that comes out to, okay? So these are very, very, very useful, very practical tools, and they're pretty simple. So I'm going to keep moving through this pretty quickly because I think you guys can get this pretty easy, all right? So moving ahead here. Solving for future value, extremely useful. I find myself doing it actually pretty often in my day-to-day life, mostly with personal finance topics. In terms of thinking about how much money I have and how much I'm going to have in the future, it's really useful. So now let's think about kind of inverting the question, okay? So rather than thinking about how much money I have now and what that would be worth in the future, we might flip that around and think about, what if I'm going to get a payment in the future? How much would that payment be worth to me? Okay, so let's get morbid here for a little bit. Let's say that I expect to receive $250,000. Maybe I'm going to get some inheritance, okay? And so I expect to receive $250,000, I don't know, in 20 years. So I'm thinking, you know, parents might die or something, and that's the amount I'm expecting to get. It's a rough estimate, but it's practical because I can think, what is the value of that to me now? Okay? If interest rates today are 3%, how much is this expected payment worth today? Students sometimes have trouble with this type of thinking because, you know, you're going to get $250,000 regardless in the future, so why does the 3% even matter? And this might help you think about it, okay? Just imagine you were a person that would like to get $250,000 in 3 years. Well, how much would you be willing to pay to do that, right? That'd be based on interest rates, okay? So this is kind of like saying, what if I put money in a savings account with the goal of having $250,000 in 3 years? How much would I need to put in now? Okay, so if I wanted to somehow sell this transaction, you can kind of picture this as being like an asset that I own. If I wanted to sell it, the present value would show me how much this is worth to me in today's terms. Okay, so I can take this formula that we just solved for, and I can just invert it to solve for the present value. Okay, so I'm just going to solve for the present value here, like so. Okay, present value is equal to the future value divided by 1 plus I raised to the n. Okay, so just plugging those values in, I'm going to be able to solve for the theoretical value of those payments that I'm expecting to get in 20 years. We'll see what it comes out to. So given the interest rates that currently are persisting in this economy, kind of think about this like the risk-free rate of return, if you're familiar with that terminology, then basically having $138,000 today has the same value as $250,000 in 20 years when you consider that 3% is the prevailing interest rate in this market. Okay? So in other words, if you're trying to figure out the practical application of this, if I know I'm going to get this money in the future and I know it's no risk and I can convince others that there's no risk, I could sell this asset off to another investor for this price. That would be the fair price for this asset in the future. The price of this asset is going to change based on interest rates, okay? So the thing to recognize is that when the interest rate goes up, the present value goes down. So if interest rates go up in this economy, basically what that means is I need to discount the value of this by a greater extent. If interest rates go up to 10%, that reduces the value of my expected future payment in the future, okay? In other words, if interest rates go up to 10%, let's just solve for it here. If interest rates here go up to 10%, let's see what that leads to in terms of the present value. Now we only get about $37,000. So if interest rates in this economy jump to 10%, that doesn't do anything about changing the value of my $250,000 payment in the future. But what it does is it reduces its value today, okay? It doesn't reduce the future value. That's still $250,000. But if I wanted to sell this asset, I'm now competing against other loans that offer a much higher interest rate. So if I want to sell my asset now, I'm only going to be able to get about $37,000 for it, okay? Which could be relevant to me when I'm thinking about perhaps the transferability of the asset that I have, okay? I'm going through this chapter like super fast. We're almost done with it because I'm really thinking that maybe everybody, certainly almost everybody, has seen this material before. And if you haven't seen it before, there's not a whole lot of discussing that needs to happen. You just really need to sit down and do some practice problems, and that will make this way easier to understand. It's not hard. It's really not hard. So we're going to be moving forward into the future to think about bonds, and really what we've been discussing so far are very much like bonds. That example I just gave you of the future payment is basically a bond. A bond is basically just a promise to provide a payment in the future. Okay? And in some case, there might just be one payment in the future. In some case, there could be a string of payments in the future. We're going to dive more into that in later, actually in this series of videos that I'm putting out right now. But when it comes to bonds, we basically can think about the different values that they are. Okay, so one thing that might happen is you get multiple payments. In the case of multiple payments, all you need to do is just string together the PVs, string together the present values. So just to give you one quick example here, this is so painfully easy, but imagine you get a payment, $500 in 6 months, and then you're going to get another $500 in 18 months. Right? Maybe these payments are rolling in from a bond that you own. Right? Maybe it's something that's not real sophisticated. Maybe it's just like a friend is going to make these payments to you, and you're trying to figure out what is the value of this today, okay? Or as an investor, how much would I need to pay in order to get these string of payments in the future? All I got to do is just take the present value of these in the same equation, okay? So if the interest rate in the economy right now is 5%, to figure out what the present value of this bond is, all I've got to do is just take two separate future value calculations or present value calculations and just add them together, right? I'm getting $500 in 6 months. 6 months is half a year, so this would be 0.5, okay? And then I'm going to get $500 again 1.5 periods into the future, okay? So again, we'll solve for this really quickly. And this comes out to about $953. Okay. So again, I really want you to understand the practicality of what this value means. Students sometimes are able to solve, but they don't really comprehend what this is telling them. Okay. What this means is if you wanted to sell this bond off, given the fact that there are tons of other bonds out there and we have an equilibrium interest rate of 5% in the markets, if you wanted to sell this off, this is probably the price you would get. Okay, about $953 on this bond. So that shows you how much this bond is worth if you want to sell it, or if you're a potential buyer and you want to accomplish a bond that gives you these payments. This shows you how much you can expect to pay. And if you happen to find one that's out of whack, if you happen to find a bond just like this that was priced at $800, well, that's a good one to buy. Okay, so this helps drive prices in the bond market. One last thing from this chapter, and then we'll be done with this quick little mini chapter. When it comes to interest rates, and thinking about value, it's not just driven by interest rates. Okay, when we think about the value of payments, okay, particularly when we consider future values, the interest rate is not the only thing that matters. So for example, if I said, I'm going to give you $500,000 in 20 years, the interest rate that we have today is not the only thing that would affect how you feel about that payment in the future. The other thing you would care about is inflation. The higher inflation is, the less the $500,000 in the future will be worth to you. Okay, so inflation also matters. So this seems like a nice time to go ahead and introduce another simple idea. This is all simple ideas in this chapter. Something called the Fischer Equation. Maybe you haven't heard of that term before, but I bet you've seen this formula. The formula looks like this. Okay, I equals R plus the pi sign, right, with a little e next to it. We need to explain what this means. Okay, this is just shorthand notation we have so far. I is the interest rate. That's what we're used to dealing with. That's the the 3% and such that we're using in the prior examples. R is the real interest rate. Anytime you see that term real, that means it's adjusted for inflation. Okay? And pi with a little e next to it is expected inflation. Turns out expected inflation is relevant because when we're thinking about future value calculations, we never actually know what the inflation rate is going to be. Okay? So anytime we're thinking about future value, when I say I'll give you $500,000 in the future, you would think about inflation, but you wouldn't actually know what the inflation rate is. So expected inflation is how we think about our decision-making processes. Probably where you've seen this before is when you're solving for real interest rate, which is just an inversion of the same formula. This formula here is exactly the same. I'm just rewriting it. But I'm showing you this because a lot of times in macroeconomics, professors will go through this real inflation rate here. And it's basically just coming to the realization that inflation actually matters quite a deal in thinking about how interest rates will be set up. Okay? So just to give you a little taste of what this might feel like in the real world, if in the year 2021, when we have very low interest rates, right? In the year 2021, if the inflation rate ends up being 0%, and that's what people expect, just for an example here, okay? And the inflation rate, or rather the interest rate is 2%, okay? So we have no inflation expectations. People expect prices to stay the same. And interest rates are 2%. Then what would the real interest rate be? Well, the real interest rate then in that case would be 2%, all right? So basically we can think about the very simple arithmetic value of these things in terms of how they're connected to one another. This is what we would see, okay? So if you add these two up, you solve for the real interest rate, okay? In 2022 now, let's imagine that inflation has gone up to 6%, okay? I think I may have just misspoke a second ago. The real interest rate is I minus inflation. You don't add these together, rather it's I minus inflation that takes you to that 2% value there. So imagine in 2022, everything else is the same, but we have this little boost to inflation, and people expect inflation to be 6%, okay? Here's the interesting thing. The real inflation rate is likely still going to be around 2%. In other words, the return that people need, once adjusted for inflation, doesn't change that much over the short run. And it really doesn't even change that much over the long run. In other words, if we need a 2% interest rate this year, there's a pretty good chance we need a 2% real interest rate again next year. What would change this is like changes in the federal policy and things like that, changes in how quickly interest rates are changing, inflation rates are changing, blah, 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 blah. The bottom line is people need a positive return or they will not engage in that activity, okay? So if you're going to try to issue a bond at a 2% rate, if I'm going to try to borrow money at 2%, no one's going to do that anymore, okay? Because they know that inflation is 6%. So basically, I'm going to probably need to give people a 2% real return, which means that I will need to offer 8% when borrowing money, okay? So the interest rate that occurs in the market is highly affected by what's happening with inflation. And when inflation goes up, generally speaking, over a long period of time, this isn't always true in the short run, but over an intermediate and long period of time, higher inflation means higher interest rates, okay? The reason for that is, imagine if they were severely out of whack. Imagine if inflation was 1% and interest rates were 20%. Well, that's a 19% real rate of return. That's very unlikely to happen in the real world because this would make savings so profitable, right? If I knew this was happening, I would really want to save money into this market. And as you save money into that market, the interest rates would go down, right? An increase in savings drives down rates. So rates would go down in this example. So that's just not going to happen. The other possibility is, you could have something like this. Inflation is 6%, the interest rate is 1%. Well, in this example, when you save money, you're effectively losing 5% in real interest. This is a negative 5% real interest rate. That sounds awful to me as an investor. So I wouldn't save money in this market. I'd go put my money somewhere else. And as people took their money out of this market, the interest rates would get driven up. So you see this tight connection between interest rates and inflation rates, okay? Over the short run, they can kind of wiggle, they can divert a little bit, but they tend to move in unison over long periods of time. So what that means is, if inflation 5 years from now is 15%, I'm very confident that interest rates will also be much higher than they are today. Probably somewhere around 17, 18%. Okay? So that's some of the basics for finance, right? This is kind of like an introduction to finance in a way. Next, we're going to think about risk. Then we're going to get into bonds and then stocks. So we're getting through some of these main ideas that we need to have in finance to start doing some analysis and combining econ and finance ideas together to think about some major events in history. We're going to think about the Great Recession, the Great Depression, financial crises, stock market collapses, and we need these basic fundamentals before we can do that. When it comes to making a financial decision, return matters, obviously, right? Expected return, we were doing that just previously in this video. The other thing you definitely think about is risk, okay? And a lot of times in our calculations, we just imagine risk doesn't exist. That's just really to simplify things and make the math easier. In reality, risk is basically always an issue. There's an issue that you'll never get paid back when you loan someone money, right? There's risks that inflation could go way up or way down. Interest rates in the future could go way up or way down. And we just want to be able to anticipate and think about how risk affects our decisions, okay? So this actually comes out of chapter 5, Understanding Risk. And a lot like we did with chapter 4, we're going to try to go through this very quickly because I'm under the impression that most people have seen these types of calculations in the past. And I don't really want you to go through and solve for standard deviation, using your hand. That just seems like a real waste of time. So instead, we're going to make sure we understand the concepts behind this and just do enough math to give us help in understanding how these ideas work, okay? So basically, risk is the anticipated or actual deviation between likely outcomes and potential outcomes. Okay. When I use the term anticipated or actual, we can kind of think about it this way. Regardless of whether there really is a risk, merely the expectation of risk is meaningful. That's what expectations theory shows us, is that when expectations change, that also changes reality. So if I think that an asset is very risky, I will adjust how much I'm willing to pay for that asset. So we can think about risk in terms of reality or the anticipated risk. A lot of times it's really about anticipated risk because the actual risk is unknown. That's what makes it a risk, right? Is there's no way to see into the future. So if I'm thinking about the future value of GameStop, and I'm thinking about whether or not GameStop will go up, I have some feel for the fact that it is very risky right now. But in reality, I don't know how risky it is. All I can do is look back at the past and see how it's jumped around, and that gives me some idea about risk. But in reality, there's no way to really even approximate what risk might be in the future, okay? So it's really an anticipation. We not only anticipate its respected return, but we also anticipate what risk might be over time. Probably the best way to measure risk, or the easiest and certainly the most common way to measure risk, is to think about standard deviation, okay? So if we want to solve for standard deviation, the first calculation we need to make is expected value. And this is really just the average outcome of any particular event, okay? So just to give you a really simple example here, let's say that you flip a coin. If you flip a coin and it is heads, you're going to earn $20. If you flip a coin and it is tails, you will lose $10, okay? To solve for the expected value is pretty simple. And this formula actually works for any type of expected value calculation. You just multiply the probability of an event times the payout of that event occurring. And you do that for all of the probabilities and all the payments that could occur. Okay, so I could put this in sigma notation if I needed to, but I think that's relatively straightforward. So for this particular calculation, the expected value is a 50% chance. So probability is in terms of the likelihood of it happening. So a 50% chance that you win 20 and a 50% chance that you lose 10, okay? And what you would get there is that the expected value is $5. Sometimes students make the mistake of thinking the expected value is the most likely outcome, but it's not the most likely outcome. And in fact, it's impossible, right? Not only is this not likely, it's literally impossible for this to happen. If you flip a coin one time, there's no way to win $5. You're either going to win 20 or lose 10. But if you could imagine that you play this game an infinite number of times, the average result is that you would win $5 every time. Okay? So standard deviation is how far you might deviate from the expected value. So standard deviation is roughly the average deviation from the EV. Mathematically, it's not exactly what I'm referring to here, but this is a nice way to think about it. Okay, so if you're trying to wrap your head around standard deviation, a good way to think about it is to think, on average, how far away will you be from that anticipated outcome? Okay, so if the EV is $5 in this game, there are two possibilities. You do $15 better than that. Okay, so if you flip it as heads, you get $20, which is $15 better than the EV. The other possibility is you do $15 worse than the EV. And if you actually go and solve for this, you'll find that the standard deviation is 15. So the standard deviation is how far away an outcome is compared to the expected value. And in this case, it literally is defined by the average deviation from the EV. Okay, the standard deviation is 15 because if you flip the coin once, on average, you're going to be $15 away from the expected value. In reality, it's not always that simple. The standard deviation calculation actually overvalues things that are further away. Basically, if an outcome is really far away from the EV, it will overemphasize that, basically because when things are far away from the EV, that tends to reflect a more risky outcome. So this is a good way to think about it, but mathematically, to be honest, it's not perfectly correct the way I defined it here. All right? When it comes to risk, as you know, risk is unavoidable to some extent. And there are basically two types of risk that we face. Probably these are terms you've seen. One type of risk is systematic. Systematic risk is basically risk that you really can't avoid if you are trying to achieve a certain level of return over time. So this is unavoidable risk. When attempting to receive or attain a given level of return. So for example, if my goal is to receive a 10% rate of return, all right, I'd really like to get a 10% rate of return on my money. There's no way to do that risk-free, right? There's no way to get risk-free 10% rate of return right now when I'm making this video in 2021. It is impossible, okay? But what I would like to do is minimize risk. So given that I would like to receive a 10% rate of return, I would like to find the lowest risk way to do that. And if I achieve that goal, I have realized an investment where I only have systematic risk. I've only taken on the required amount of risk to receive a given rate of return. If I take on even more risk, if I take on unnecessary risk, that also has a name, and that is called idiosyncratic risk. Idiosyncratic risk. So this is risk that is above and beyond what is required to receive a certain level of return, okay? In other words, this is risk that is not connected to additional compensation. This is risk you don't get compensated for, okay? So when you take on any given level of investment, like trying to receive a 10% rate of return, there is some risk you have to take on. Now imagine you choose to take on even more risk. That extra risk that you take on that doesn't make your goal any more likely to be achieved, that's called idiosyncratic risk. Let me give you just a nice, clean, simple example of what I mean by this. Let's say your goal is to have an expected value of $5. Okay, so we're going to flip a coin, and your goal is to have an EV of $5. In one game, you've got this option. This is the game I just showed you a second ago. One game, you got option 1 here, all right? Flip a coin. If it's heads, you get 20. If it's tails, you get 10. Or, excuse me, lose 10. And in the second game here, if it's heads, you get 40, and tails, you lose 30. Each of these games have the same EV. The expected value is $5. And the difference between these games is not the expected level of return, of course. No, it's the risk. The standard deviation here for this game, if you solve for it, would be $15. The standard deviation for this game would be $35, okay? And let's imagine these are the only two options you have, all right? If you want to get $5 right now, you've got 2 games you can play. If you play game 1, the risk that you've received is all systematic. In other words, to receive an expected return of $5, there is no game that has less risk than G1 here, okay? So all of the risk is systematic risk. G2 also has systematic risk. In other words, there is risk that is yielding return. But there's also idiosyncratic risk. There's also risk that isn't creating any more return, okay? So most people would choose to play game one. They would choose to take on systematic risk without any idiosyncratic risk. And the goal for investing for a lot of people is really just to boil it down to just systematic risk. So to state that in a different way, to receive more return, right? To receive a higher level of expected value, you must take on more risk. That's a very common thing in finance, right? That if you want more return, you have to accept more risk. Or to put it another way, if you're willing to take on more risk, that sometimes leads to more compensation. This is risk that is inherently systematic, okay? So right now, if you're getting a 5% rate of return in bonds or something, and you want to jump to 10%, you're going to have to take on more risk, all right? The risk that you're taking on there is likely systematic. It's risk that you must take to get a higher level of return. Sometimes people want to flip this around and they make a mistake, and they think if you take on more risk, you will get more return. The opposite is not true. More risk doesn't always generate more returns. I've had some students have a lot of trouble with this in the past, but imagine if a homeless person walks up to you and says, "Hey, can you lend me $20? I'll pay you back in a week." That has no return, right? In terms of, he's just saying, "I'll pay you back." The interest rate there is 0%. You give him $20, in a couple weeks he'll give you $20 back, maybe. So that has no return. It's also extremely risky because it's very likely he's not going to pay you back, right? You really don't know if he's going to. Maybe it's a 50-50 chance he does. So that is no return and high risk. The fact that you're loaning that money to a homeless person makes it risky, but it doesn't somehow make it a higher return, okay? So you can take on risk without getting any more return. That's the problematic type of risk. That's that idiosyncratic risk that I really try to encourage people to avoid when they're thinking specifically about their personal finance and retirement goals. Okay, when it comes to risk, you can take on one of three attitudes. You might think about how you fit into each of these risk profiles. One possibility is you're risk-loving, right? This is unusual when it comes to large sums of money, but you do actually see it from time to time. Risk-loving basically means that for two games or investments or what have you, okay, that have the same EV, you'll choose the riskier one. All right, so in other words, you actually get value or utility out of risk. So this often will correlate with, if there are two games that have the same or even different EVs, you might actually choose the one with the lower EV if it's very risky. That might sound like kind of a stupid thing to do, but anytime you buy a lottery ticket or go to a casino, this is basically what you're doing, is you're intentionally taking on risk. So if you think about like a lottery ticket, like a dollar scratch off, the EV on buying one of these lottery tickets is about negative 50 cents. In other words, if you buy a $1 lottery ticket in Georgia, on average, you lose 50 cents on that ticket, okay? But I bet if you're watching this video right now, you probably bought a lottery ticket. So when you did that, you were extremely risk-loving, okay? And the reason you're willing to buy it, likely, is because of the extremely high levels of risk, right? That chance that you could win a lot of money. So people tend to be risk-loving occasionally at certain periods of their life when dealing with small amounts of money. When it comes to big amounts of money, normally in finance we're thinking about big sums of money. People are not risk-loving. Instead, they are risk-averse. So for two games with the same return or the same EV, choose the one with lower risk. Okay? And so basically, somebody who's risk averse, who is most people when it comes to their retirement planning, they're going to basically avoid risk. And if you think about what that means, if there's two types of risk, systematic or idiosyncratic, if you're trying to avoid risk, you're going to have no idiosyncratic risk. You're going to completely avoid idiosyncratic risk and only be left with the risk that is unavoidable at a given rate of return, right? The systematic risk. So let's think about a couple of different options here, some games. So more games here. Game one. This maybe is investing. Rather than think about expected value, let's think about expected return, 10%. And let's think about the standard deviation. This is kind of like investing in the stock market over a given year. You know, over a given year, the expected return is about 10%, and the standard deviation is about 20%. So if you invest in the stock market for an entire year, you wouldn't be too surprised if you earned a 30% return or negative 10% return. That would kind of be a normal deviation from the mean there. So you could do that, or maybe you could invest in the second game that looks like this. Okay? So this maybe is like investing only in stocks. Maybe this is like putting half your portfolio in bonds and half in stock. Think about the choice that a person would make here, okay? If you are risk averse, it's actually not certain which of these you would choose, okay? For somebody who's risk averse, it's kind of hard to tell which of these they would choose. So if I ask a multiple choice question, if Bill is risk averse, will he choose game one or game two? The answer is actually we don't know, okay? For Bill, who's risk averse, he still doesn't like the fact that the return here is lower. He still likes return. Everybody likes positive returns, right? So he prefers the higher return of game one, but he prefers the lower standard deviation of game two. So for someone who's risk averse, we can't for sure say what they would do. If they're extremely risk averse, they would play game two. If they're just barely risk averse, they would probably choose game one, all right? Compare that to somebody who is risk loving. If they're risk loving, they're going to play game one, all right? Because it has two things they like. They love the 10% return, and they also love the fact that it has a higher level of risk. So if you're risk loving, you're going to choose game one. What if you don't care about risk at all? All right, that's called being risk neutral. If you're risk neutral, you're just always going to choose the one with a higher return. So you would choose game one, okay? Compare that now to the following. Okay? Game one versus game two. All right? Game two clearly has idiosyncratic risk. All right? It has the same level of expected return as game one, but it has even more risk. So therefore, the extra risk is all idiosyncratic. It's completely avoidable. Okay? So if you're risk averse, you would clearly choose game one. Right? Same return, lower level of risk. If you are risk loving, you would clearly choose game two because you actually like receiving more risk. And if you're risk neutral, technically you wouldn't care. Risk neutral means you don't care at all about risk. You're completely indifferent to it, so you wouldn't care which one to play. And let's just do one more example here. In this example, all right, first of all, think about if you're risk averse. I think if you're risk averse, it's pretty obvious, right? If you're risk averse, you get a higher expected return from game one, and you get a lower level of risk from game one. So if you're risk averse, you are clearly going to play game one, okay? If you're risk loving, what would you do? This is where you got to be careful again. If you're risk loving, we actually can't tell what your choice would be. It depends on how risk loving you are, right? If you're risk loving, you do prefer game one for the expected return. Everybody likes positive returns, okay? So you like that part. But if you're risk loving, you actually prefer the risk of game two. So we can't actually say what you would do if you're risk loving. It depends on the extent of which you prefer risk. Are you extremely risk loving? Well, then this one's going to look pretty good to you. Are you just barely risk loving? You'll probably choose game one. And then finally, if you're risk neutral, you would choose game one because all you care about is the expected level of return. Notice in this example, all right, not only does game two have more risk, it also has a lower level of return. So this is like idiosyncratic risk to the extreme, right? Not only do you have unnecessary risk, but it is creating a return that's lower than expected. So this is a scenario where, you know, most people, because most people are risk averse, they would never do option two here. But there's always those few people out there that really get a kick out of risk. So there'll still be some buyers, I'm sure of it. All right, so most people are risk averse. Most people are risk averse. So what that means is they're going to try to figure out ways to avoid risk. In particular, they're going to try to figure out ways to avoid idiosyncratic risk first and foremost, okay? Everybody would like to, well, everybody who's risk averse would like to at least eliminate idiosyncratic risk. And beyond that, you're also often willing to eliminate systematic risk as well, right? Like, imagine you're 70 years old. You're probably not going to hold all your money in stocks, even if you think the expected rate of return is really high, because it's just not worth the risk, even if it's systematic. So when it comes to avoiding risk, there's a few options here. You can just not invest, all right? You know, just stay out of the game. When it comes to these heads and tails and flipping coins, just don't flip coins at all. That's one possibility. Of course, that is generally not reasonable. You're going to have to take on some level of risk. And in fact, when you think about it, it's almost impossible to avoid risk entirely. If you don't put your money in the stock market at all, you just keep it at your house, you know, keep 100 grand at your house, you still got inflation risk. So it's really difficult to avoid risk altogether. So practically, we need to think about ways to avoid risk. One way to do this is to hedge. And for now, we're just thinking about just generically what this means. And then we're going to actually see some examples of this in the real world where you actually can risk. We'll do that in the later chapters. Hedging risk basically means that you're going to buy or invest in assets that have inverse correlations with one another. If that makes sense. Okay, in other words, you're going to invest in things where if we're talking about stocks, you invest in two companies where if one stock does well, the other one does poorly, and vice versa. You're hedging your bets, okay? So just to give you an example of this, let's say that you have a game that looks like this. Same old game that I've shown you before, okay? You'd like to play this game, right? But you'd also like to reduce your level of risk. So what you might try to do is find another game that looks like this, okay? And this is all obviously fantasy world because there's no games that just give you these, very high levels of return for, pretty small level of risk, really. But imagine if you could play these games 10 times, all right? So I'm sitting there flipping a coin and I say, I'm going to flip a coin 10 times. You can play game one or game two, and you can play them at the same time if you want. To reduce your risk, what you would do is you would play game one and game two at the same time that I flip a coin. So if I flip a coin and it's heads, right, you win 20 here, you lose 10 here. If I flip a coin and it's tails, you'd win 20 here and you'd lose 10 here. So you've efficiently made it a no-risk game for you. That's hedging, okay? If you just played game one 10 times, that would yield the expected return that is exactly the same of playing both of these games five times at the same time, 5 times simultaneously. But you reduce your risk if you can somehow play these games simultaneously. That's not really practical, is it? Right? Because these games don't really exist in the real world. Instead, here's how it might look in the real world. It's 2021. We're thinking about a vaccine, right? Vaccines do exist, but there's always risk that we get major side effects or something, okay? So basically, here is the possibility. COVID is basically uncertain at this moment in time in terms of how it's going to affect us. You think there's a possibility that COVID lasts for years, and you think there's a possibility that the vaccine just completely just destroys COVID, and a year from now we're not talking about it anymore, okay? You would like to yield positive returns. Let's think about how you could do that, okay? If COVID ends up lasting for years and is a really, really big problem for us, you could invest in a company like Netflix. Buy some stock in Netflix. Right? Netflix is going to do pretty well during COVID because people have to stay home, so they're going to be more likely to watch TV, right? And in fact, during COVID, Netflix has done really well. The other possibility is, what if we destroy COVID and it's gone in like a week from now, okay? Well, now Netflix is going to suffer because people are going to say, hey, let's just go out to the movies. Let's cancel our Netflix subscription, right? Let's go on vacation. Well, if that happens, you might invest in something like, I don't know, Pfizer, maybe Delta, something like that, right? Pfizer, because maybe they're going to get a lot of really good press and a lot of profits from their vaccine. Or maybe Delta, because you're thinking people are going to be flying after COVID is gone. So you could buy stock in one of these companies, perhaps, right? And in doing so, you've kind of hedged your bet. If COVID sticks around, all right, you got a good stock for that. If COVID goes away, you got a good stock for that. You've hedged your bet. Regardless of what happens, you're going to do okay, all right? It's not perfect, okay? Maybe your expected level of return is unknown. Maybe it's really high, maybe it's really low. It's kind of hard to know. And it's really hard to know about risks too. But this is definitely less risky than just buying one or the other, right? If you just buy Netflix stock and then COVID is completely eliminated, you're going to do poorly, okay? So you're hedging by getting companies that have an inverse relationship in terms of their expected return. That's hedging, okay? Sometimes practical, but a lot of times it's really hard to tell how the correlation actually persists. And kind of the weird thing in finance is that it's actually really hard to predict what's going to happen in the future because everything is really unknown, okay? So we can think about now and think about what happened with COVID, but, you know, a year and a half ago, no one was thinking about the possibility of a pandemic. That was just not on our radar. And that's the frustrating thing about these adverse events in economics, is that they're not anticipated, all right? By nature, they're not anticipated. If we had known COVID was coming, we could have been a little bit more prepared. The stock market would have dipped way before COVID hit us, okay? But since it hit us so quickly and so unexpectedly, you get this massive drop in the stock market and we're all scrambling trying to figure out what to do. So in reality, we don't know what's going to happen in the future. So what you can really do is not hedge your risk, because that is often impossible, and instead just spread your risk. This is saying, look, I don't even know if Netflix and Pfizer are really uncorrelated with each other, because I don't know what's going to happen in the future, all right? There are definitely scenarios where both Netflix and Pfizer do great. Maybe COVID goes away and Netflix opens up a bunch of movie theaters. Well, now they're both doing well, right? So you don't really know what's going to happen. So spreading risk is basically investing in many assets since the correlation of risk is unknown. In other words, we don't really know how different stocks are correlated with each other in the future. We can only look and see what's happened in the past. Okay, so to give you an example of what this looks like, this is actually what you're going to do with your investing, most likely. If you want to invest, you know, you could invest in Apple. Okay, just the company Apple. You put all of your money into Apple. The expected return there is about 10%. All right, just based on historical returns of stocks in general, we might expect Apple to return about 10%. That's really our best guess. Okay, another possibility is we might invest just in tech stocks. Okay, that's spreading your risk. All right, it's spreading your risk because now you're not just putting all of your, excuse the pun, apples in one basket. You're putting it into many different stocks. So now you got Apple, Google, Microsoft, et cetera, et cetera, et cetera, right? The expected return on this is also still just 10%, okay? Because the expected return in the stock market in general is about 10%. If we thought this was going to do better than 10%, the price would have already been higher, okay? We'll talk more about that in the future, something called the efficient market hypothesis, okay? So what you're doing here, though, is you're reducing your standard deviation. And to go even farther with that, you could just invest in the entire market. You might invest in what's called an index fund that tracks the entire market. If you want to look one up and just kind of get a feel for what it is, this one's the most famous, VTSAX. I'm not even going to go into it anymore. Just search that in Google and you'll get an idea of what this looks like. So you could invest in the entire stock market. Again, this doesn't change the return. You're still only going to get about a 10% expected level of return. But that will reduce the risk. All right, all we're really saying here is we don't know how stocks are correlated with one another, and rather than even trying to figure it out, let's just diversify as much as we possibly can. If I want to get a 10% rate of return in the stock market, the best thing I can do is just invest in everything. Some will go up, some will go down, but I don't even really care which ones are going up and going down because I own them all. All right, invest in the entire market. So that is called spreading risk, and that is actually a very practical way to deal with this problem. All right, we've been talking mainly about stocks. In the next chapter that we're going to move into now, let's talk about bonds.